Welcome, ladies and gentlemen. This is video number 4 in our bonding unit, and this video is going to be on how to draw covalent bonding. How do you draw covalent bonding between multiple nonmetals? So first up, you have to have your notes open to page 32 in the notes, please. And a periodic table would also be helpful because we're going to be talking about Lewis structures, about Lewis dot diagrams. So periodic table for the valence electrons. So first step, when we talk about drawing covalent bonding, what we're really talking about doing is drawing a structural formula. So what is a structural formula? It's simply a drawing that shows the covalent bonds, and it typically shows the covalent bonds as dashes or small lines. So for example, with CCl4, this right here is the structural formula, this whole thing. That is the structural formula for CCl4. You'll notice that it's drawn out. Instead of just saying CCl4, now we're showing the bonding. We're showing how the carbon is bonded to the chlorine. And each dash that you see, and this is a massive, massive point, represents 2 electrons because there are 2 electrons in a bond, in a covalent bond. So every time you see a dash, that indicates that there are 2 electrons. Now, if we look at this from the point of the octet rule, how many electrons are surrounding the carbon? Well, surrounding the carbon, we have this dash, this dash, this dash, and this dash. And each of those dashes represents 2 electrons. So, okay, each of those dashes, 2 electrons. We have a total of 8 electrons that are surrounding the carbon. So that carbon is obeying the octet rule. It has 8 electrons around it, so therefore it is like a noble gas, so therefore it is energetically stable. It has that low energy. So how do you draw this? How do you know if you have a correct drawing that is obeying the octet rule? That's our goal. That's what this is going to show. In order to start, you want to draw your Lewis dot diagrams. So if we want to draw the bonding in chlorine, which is a diatomic, Cl2, you want to start by saying what are the atoms in chlorine. Obviously, there are 2 chlorines, right? So you go to the periodic table and you say chlorine has got 7 valence electrons. So you're going to draw 2 dot diagrams for chlorine because there are 2 of them, right? Each representing the 2. That's where it starts. It always starts with your Lewis dot diagram. Then you want to see where the single valence electrons are, the ones that aren't paired, and rearrange your atoms so that they're facing one another. Now, for this structure, it's this electron and this electron. See how they're not paired up? See how all the other electrons in chlorine are paired up? You want to focus on that single ones, those single ones, because those are the ones that are going to be involved in bonding. And we want to just rearrange our drawing so that all our single electrons are facing one another. Now for this drawing, really what that means is that we can literally swap the single valence electron being on the right side here to putting it on the left and having that double be on the right side instead. That way the single ones, they're facing one another. So just like that, right? All you're doing is sort of redrawing those 7 valence electrons. The next step is with these single valence electrons, they're going to be sharing electrons because they're nonmetals. So we can represent this sharing. The ones that they're going to share are the singletons, the unpaired electrons. Those are the ones that are going to be shared. So we want to, right here, like it says, connect these single ones. Basically, you're playing connect the dots, and to show that, okay, those are going to be the electrons that are going to be shared. And then when we look at it, that, okay, this chlorine here is sort of sharing, has access to not only the single electron here, but also the single electron in this chlorine. Now that chlorine has got 8, and then this chlorine that's on the right, it will, again, have access to not only the single electron that it's putting forth, but also the single electron from the other chlorine. Well, now each of them is going to have an octet. And then the last step, which is really, really important, you want to rewrite it, sort of just rewrite your drawing to show those shared electrons as the bond. That right there, those 2 shared electrons, that is your covalent bond. That's how we draw it, as a single line. And that's it. That's how we draw covalent bonding. So I have another example for you. We're going to draw the bonding in water. Again, we want to start by drawing the Lewis dot diagrams for all of the atoms that are in water. So you're going to have an H, an H, and an O, right? 2 H's and an oxygen. Hydrogen has got 1 valence electron. Oxygen has 6. So we start by drawing the Lewis dot diagrams. Order doesn't really matter. Where you're putting the single electrons right now doesn't matter. So you want to, because your first step is to start by rearranging your atoms and the single electrons so that all the single electrons are facing one another. Like if you look right here, the single electrons between oxygen and hydrogen are facing one another. So that's good because that's where our bond is going to be. But then if we moved this H and we maybe put it over here, and then we put its electron so that it's facing the single electron on oxygen, because it's these guys that are going to be participating in bonding. So just literally, I'm rewriting, I'm reorganizing. I am allowed to put my atoms in wherever I want on the page so that they're facing one another. All right, so now that I've lined up my single electrons, these are the ones that are going to be involved in bonding. Now I'm going to play connect the dots. I'm going to play connect the dots until all of them are paired up. So I'm going to connect my single ones from hydrogen and my single one from oxygen, and then again on the other side. So this time I'm actually making 2 bonds. And then I'm just going to redraw to indicate as a solid line that that is my Lewis dot diagram for water. Rewrite it as a straight line. And again, this oxygen, it has access to, you know, these 2 electrons right here, these 2 electrons right here, but also all of the electrons in the bond. The hydrogen has access, on this side has access to these 2. This hydrogen has access to these 2. Hydrogen is actually only stable with 2. It's the duet rule because it only has 1 energy shell, and so it fills up that first shell with 2, and it's good. But oxygen needs 8, and so everything has got a stable number of electrons. Unshared pair. So you'll notice that we have those electrons that aren't involved in bonding. We have a word for that. That's called a lone pair. I'm going to call that a lone pair. It's occasionally referred to as an unshared pair. And it's the electrons that aren't shared in bonding. It's the ones that aren't participating. They're still valence electrons. They're still on the outside, but just they're not involved in bonding. So for an example here, we have our chlorine structure back again. Each chlorine atom here has 3 lone pairs. So 1, 2, 3 lone pairs, right? A total of 6 electrons, yes, but 3 lone pairs. And again, 1, 2, 3. So looking at the water structure that we have, which I redrew slightly because this actually represents what water looks like more in 3-dimensional space, a slightly bent shape. How many lone pairs surround the oxygen in water? Well, if we focus on just the oxygen, we have 1 lone pair here. We have a second lone pair here, so we have 2 lone pairs. Lone pairs of electrons, indicating that these electrons are not shared in bonding. Now, double and triple covalent bonds. Sometimes atoms need to share more than 1 electron with another atom in order to achieve a stable octet. Sometimes you're going to be making more than 1 bond between 2 atoms. And then we have double and triple covalent bondings. A double bond, 2 atoms will share 2 pairs of electrons. So between 2 things, you will actually have 2 lines. You'll have 2 pairs of electrons. And a triple bond, well, okay, sometimes between atoms we need to share 3 pairs of electrons. So a total of 6 electrons being shared between 2 atoms, all in terms of getting that stable octet so that they can be like the noble gases. So an example here, carbon dioxide, CO2. In carbon dioxide, we have 2 double bonds. You'll notice that now we have 2 lines rather than just 1 line. Remember, each line is 2 electrons. So here, in this double bond, we have 4 electrons total that are being shared. Right? Each line is 2 electrons, so 2 lines means 4 electrons. Then if we just look at the central carbon, how many electrons are surrounding this carbon? 1 dash still means a bond, and a bond is 2 electrons. So how many electrons are surrounding this carbon? Well, we have 2, 4, 6, and 8, right? 8 electrons surrounding the carbon, so the carbon is stable. So you're going to draw this into your notes. I know they didn't exactly have the space, but we're going to draw the Lewis structure for oxygen, O2. And I want you to see that it's the same process as drawing Lewis structures for single bonds, but sometimes you just need to pair things up more than once. Maybe you have to pair them up twice or 3 times. So if we want to draw Lewis structures for O2, we start the exact same way. We're going to draw 2 oxygen atoms because that's what's in the compound. We go to the periodic table, we look up how many valence electrons does oxygen have. It has 6 valence electrons. So you're going to draw the 6 valence electrons as dots around the oxygen. So there we go. I drew 2 O atoms. Each of them have got 6 valence electrons. Next step, same next step. Redraw your Lewis structure so your single electrons are close to one another, so that they're facing one another. And you are allowed to swap locations. So what I'm going to do here is I'm going to swap where I put the lone pair. I'm going to switch the location because I see right now that these two guys are facing one another, which is good. But right now these two guys are not facing one another, which is not so good. So all I'm going to do is just redraw my Lewis dot diagram so that now they're kind of more facing one another to indicate that these are the ones that are going to participate in bonding. Next up, I'm going to play connect the dots because those single dots are the ones that are going to be involved in bonding. So I'm going to hook up these guys and these guys right here. And then this is actually a really critical point. You need to redraw your Lewis structure here because the bond has to be in between your atoms. You don't really want to put it on the bottom. See how it's more like on the bottom underneath where you put the O? It needs to be in between the symbol, like we have here. So you just sort of want to take that little step, and once you figured out what it is, then you're going to redraw it. Now notice we had to connect the dots not just once, but twice, right? We had to connect these guys, and then we had to connect these guys. So this is a double bond. There is a double bond in oxygen atoms. How many electrons are being shared here? Well, we have a double bond, so that is 2 lines, so 4 electrons. 4 electrons in that double bond. So that is the end of this particular video, and we will be practicing drawing covalent bonding in class.